There's something out there, right now, orbiting our sun, and we can't see it. Not because it's too far, not because our telescopes aren't powerful enough, but because it might literally be invisible. A black hole, roughly the size of a grapefruit, silently circling our own star for 4.5 billion years. And here's the part that should keep you up at night. We only just figured out it might be there. By the end of this video, I'm going to show you exactly what NASA found, why the world's top astronomers are taking this seriously, and what it would actually mean if a black hole has been hiding inside our solar system this entire time. Stick with me until the end, because the final reveal completely changes how you think about the universe we live in. But before we get there, quick question. Where are you watching this right now? Drop it in the comments. I genuinely want to know. Okay. Let's go back to It starts not with a black hole. It starts with a wobble. A tiny, almost undetectable wobble in the orbits of objects at the very edge of our solar system. Objects so far from the sun that light itself takes over 12 hours to reach them. We're talking about a region of space so distant, so cold, so poorly understood that most people don't even know it exists. This is the outer solar system. Beyond Neptune, beyond Pluto, a frozen, silent frontier stretching hundreds of billions of kilometers in every direction. And out there, astronomers started finding something strange. Small, icy worlds, not planets, not moons, just chunks of rock and ice drifting in enormous, stretched-out orbits. Scientists call them extreme trans-Neptunian objects, and individually, none of them are particularly shocking, but together they tell a story that nobody expected. Here's the thing about orbits. Over billions of years, the gravity of the giant planets, Jupiter, Saturn, Uranus, Neptune, should randomize the paths of distant objects, scatter them in every direction, like shuffling a deck of cards over and over until the order is completely random. That's what physics predicts. That's what should be happening. But when astronomers mapped these distant objects, that's not what they found. Instead of random scattered orbits, these objects were aligned. Their closest points to the sun were all clustering in the same direction of space. Their orbital planes were tilting at similar angles, as if something massive and invisible was herding them, organizing them, pulling them into formation like a cosmic traffic officer nobody could see. Astronomers ran the numbers. The odds of this alignment happening by pure chance? 0.007%. That's roughly 1 in 15,000. That's not a coincidence. That's a signal. Something is out there. Something enormous. Something we've never seen. In 2016, two astronomers at Caltech, Konstantin Batygin and Mike Brown, published a paper that shook the entire field. Their conclusion was simple. There has to be another planet, a massive, undiscovered world somewhere between 5 and 10 times the mass of Earth, orbiting the sun at an almost unimaginable distance. So far out that a single trip around the sun would take it between 10,000 and 20,000 years. They called it Planet 9. The scientific community paid attention. Computer simulations confirmed it. Add a planet with the right mass and the right orbit, and suddenly everything made sense. The clustering, the tilted orbits, the strange high-angle paths of certain distant objects. One hidden planet explained all of it. Telescopes pointed toward the sky. Search teams formed. The hunt began. And then, nothing. Years passed. Powerful observatories scanned the regions where Planet 9 should be. The Subaru telescope in Hawaii, infrared surveys, deep sky imaging. All of it came back empty. Planet 9, if it existed, was hiding perfectly. And that's when a small group of researchers asked a question that nobody had seriously considered before. What if it's not hiding? What if it simply can't be seen, not because it's in the wrong part of the sky, but because it emits absolutely zero light at all? In 2019, two physicists, Jacob Schultz from Durham University and James Unwin from the University of Illinois, published a paper that proposed something extraordinary. What if Planet 9 isn't a planet? What if it's a black hole? Now, before your brain shuts that down as science fiction, hear this out because the reasoning is genuinely hard to argue with. From a gravitational standpoint, a black hole with 5 times the mass of Earth would behave identically to a planet with 5 times the mass of Earth. Same gravitational pull, same orbital influence, same effect on those distant icy objects. You couldn't tell the difference just by watching how nearby objects move. But here's the key difference. A planet reflects sunlight. A planet has a thermal signature. A planet, even billions of kilometers away, eventually shows up in a telescope. A black hole? A black hole reflects nothing. It emits nothing. It is, by definition, invisible. If Planet 9 is actually a primordial black hole, a relic from the first fraction of a second after the Big Bang, then every telescope in the world could be pointed directly at it and still see nothing but empty space. And that would explain exactly why we haven't found it yet.
So here's what we're actually talking about. A primordial black hole, formed in the first microseconds of the universe, when space itself was so dense and chaotic that regions of matter could collapse directly into black holes without ever becoming stars. These objects have no minimum size, no lower limit. They could be the mass of a mountain, the mass of an asteroid, or, in the scenario that keeps astronomers awake, the mass of a small planet. A black hole with 5 times Earth's mass would have an event horizon, the point of no return, roughly the size of a grapefruit. You could hold a glass around it, but its gravity would be devastating. And from hundreds of astronomical units away, its gravitational fingerprint would look exactly like a planet. Schultz and Unwin went further. They pointed to a separate, independent dataset, a gravitational lensing survey called OGLE, which detected 6 ultra-short lensing events that couldn't be explained by known objects. The best candidates? Small black holes drifting through the galaxy. If those black holes exist in our galaxy in large numbers, then statistically, the Sun could have captured one, pulled it into orbit during a close encounter with another star system billions of years ago. And it's been there ever since. Silent, patient, invisible. Now here's the moment from the very beginning of this video, the thing I told you we'd come back to. The reason this isn't just a fringe theory, the reason NASA and major research institutions are genuinely engaging with this idea, it's because we now have potential ways to find it. If a primordial black hole is orbiting our Sun, it would be surrounded by a halo of dark matter, particles that have accumulated around it over billions of years. When those dark matter particles collide, they annihilate, and that annihilation produces high-energy gamma rays. Gamma rays that could be detected by space telescopes like NASA's Fermi Gamma Ray Space Telescope. There's also the possibility of detecting flares, brief, intense bursts of light produced when a small object, like a comet or asteroid, falls too close and gets shredded by the black hole's gravity. Researchers Amir Siraj and Avi Loeb proposed that the Vera Rubin Observatory, which began its full survey in 2025, could catch exactly these kinds of events. And the Rubin Observatory is already returning data right now. Thousands of new trans-Neptunian objects, cleaner orbital maps, a far more complete picture of what's happening at the edge of our solar system. Within the next few years, we will know whether Planet 9 is real. We will know whether the orbital clustering holds up when the sample size expands. And if it does, if everything points to a single hidden massive object, then the next question will be the most important question in modern planetary science. Is it a planet, or is it something that has been hiding in our solar system since before the Earth existed? Think about what that actually means. If there is a black hole orbiting our Sun, it's been there longer than life on Earth, longer than the oceans, longer than the Moon. The entire history of our planet has unfolded inside a solar system that contained a black hole, and we never knew. That's not just an astronomical discovery. That's a complete rewrite of how we understand the place we live in. We've mapped Mars. We've touched the outer planets. We've found thousands of worlds orbiting distant stars. But right here, in our own backyard, there might be something that has been invisible to us this entire time. And we are finally close enough to the answer to feel it. If this video changed the way you think about our solar system, share it with someone who needs to see it. And stay tuned, because when the Rubin Observatory data comes in, we're covering it the moment it drops. The universe is not done surprising us. Not even close.